Let us prove the inequality mod of sin b minus sin a is less than or equal to mod of b minus a for any two real number a and b. So we want to prove this inequality. Let's call this one to be inequality 1. We'll be applying Lagrange mean value theorem. Observe that if a equal to b, then the inequality is obviously true. If a equal to b, comma, 0 is less than or equal to 0, so true. We assume a is not equal to b. If a is not equal to b, then either a is less than b or a is greater than b. Further, we assume without loss of generality that a is strictly less than b. This is a reasonable assumption because if a were greater than b, we can simply interchange a and b, and we know that modulus of minus b is same as modulus of b. So the inequality will be true. Now we divide inequality 1 throughout by mod of b minus a. Let us divide inequality 1 throughout by mod of b minus a. Right inside you see that mod of b minus a will get cancelled, and we can divide because a is not equal to b, so we are not dividing by 0. Now you see that it reminds us something about Lagrange mean value theorem. Let us recall Lagrange mean value theorem. Lagrange mean value theorem: if f is continuous on the closed interval a comma b, differentiable on the open interval a comma b, then there exists a constant c such that f dash c equal to fb minus fa by b minus a. We got similar result, right? We can write it. That is, we want to show that mod of sin b minus sin a divided by b minus a is less than or equal to 1. So we got fb minus fa by b minus a. We should choose fb equal to sin b, or rather fx equal to sin x. Let fx equal to sin x on the closed interval a comma b. Does it make sense? Yes, we are assuming a to be less than b. So fx equal to sin x. Is this function continuous? Yes, f is continuous on the closed interval a comma b. Is this function differentiable? Yes, f is differentiable on the open interval a comma b. For differentiability, we don't need a whole of the closed interval, we just need the open interval. In fact, fx equal to sin x is differentiable throughout R, and the derivative of sin x is cos x, but we don't need every real number, we just need real numbers on the open interval a comma b for differentiability, and for continuity we just need closed interval a comma b. So by Lagrange mean value theorem, there exists a constant c such that f dash c equal to fb, that is sin b, minus fa, that is sin a, divided by b minus a. But how much is f dash c? Fx equal to sin x, and f dash x is the derivative of sin x is cos x. So f dash c is cos of c. There is constant c, such that cos of c equal to sin of b minus sin of a divided by b minus a. But now we can take modulus, and of course that c lie in the open interval a comma b, though it is not necessary. Now if we take the modulus both sides, we obtain modulus of cos c equal to modulus of sin b minus sin a divided by b minus a. But we know that modulus of cos c is always less than or equal to 1. From there we conclude by multiplying by modulus of b minus a to say that sin b minus sin a is less than or equal to b minus a. Now we can choose a equal to 0. That's not part of the question, but we can choose a equal to 0 and b equal to theta, and say that sin theta is less than or equal to theta, again modulus, And further we say that modulus of sin theta by theta is less than or equal to 1.